Again, welcome to Precalculus course. In these lectures, we are going to cover the sets and also set operations. So we start with what is a set, and here we have the definition. So we say a set is a well-defined collection of objects. And also there are two ways to tell what a given set contains. And one way is by listing the elements or members of a set. So example given here, we have set A. And the members or the element of the set are 1, 2, 3, 4. So we start with the curly brace and we cross it. Now, another way of using it, we can say that, for example, 4 is a member of set A. So we can say 4 belongs to A. The symbol here means belongs. Or similarly, we can say, okay, 5 doesn't belongs, or 5 is not a member of set A. So here also, we have some concept called affinity set and infinity set. Affinity set is a set that we can list all the members or the element of the set. Example, set A is affinity set because you have 1, 2, 3, 4. Set B also is affinity set because it has the element are X, Y, and Z. Now, normally infinity set, we are going to end it with a 3 periods, which means again, the element continuous. So example given here, we should write the following set in two ways. Again, we saw the previous example that we can use the curly brace or we can use the symbol belongs or not belongs or half or not half. So we start with first a set A of a natural numbers less than 6. So this will be a natural numbers are normally positive values and from 1. So less than 6 means set A members will be 1, 2, 3, 4, 5. Or we can write it in this form. X is a natural number less than 6. Now we have set B of a natural numbers greater than 10. So this will be an infinity set B. So the one way is writing B equal to 11 greater than 10. So we start from 11. All the way we have 3 periods here. So this is infinity. Or we can write in the form of X is a natural number greater than 10. And the next one is a set C contain only 3. So that means set C have only one member 3. So we have C equal to 3. Or we can say X equal to 3. Now, again, also it's possible that a set may contain no members. In this case, we may say an empty set. So this will be the symbol, or we can use the null symbol. So a null set means the set doesn't have any member, it's empty. So now we have set X and Y are equal only if they contain the same element. So for example, if X equal to 1, 2, 3, 4, and set Y have 4, 3, 2, 1, we can say X is equal to Y because the members of the order doesn't matter. I mean, the sorting. So here we have 1, 2, 3, 4. Here we have 4, 3, 2, 1. They are the same, or they are all the same members. And also next, we say A is called a subset of B, which means all the elements in A, they are also in B. But there are some elements in B that is not in A. And we can use this symbol, which represents A is a subset of B. This means if every element of A is an element of B, but there may be some element of B that is not in A. So for example, we have set A equal to 1, 2, C, and F. Set B is 1, 2, 3, A, B, C, F. We can see that all the elements in set A, they are also in set B. But there are some elements in set B that is not in set A. So here we can say again, A is a subset of B. And we can use the symbol A is a subset of B. Now, if we have C and D, we have set C and D, and set C and D have no elements common, then we call it a disjoint, which means you have two sets. The element in C is different from the element in D. They don't have anything in common, all the elements. So for example, given here, if C equal to 1, 2, AB, and set D equal to 3E, BC, then we can say set E and B are disjoints because all the elements in set C is different from all the elements in set B. So we have something we call the universal set. Normally, universal set will be all the elements in any possible material category. For example, English alphabetical letters is 26. So if I'm doing some work and we are relating alphabetical words, then the universal set will be all the possible characters from A to Z is the universal set. And normally we can use the Venn diagram to illustrate the relationship among different sets. So let's see an example here. So we saw the preview, the subset. So B is a subset of A. So we can see B is inside A, which means all the elements in B, they are also in A. But there are some elements A that are not in B. So that's why the B is a subset of A. Here we have disjoint because we can see M and N, they don't meet. So which means all the elements in M is different from all the elements in N. And this is again using Venn diagram. Now here we say X and Y are not disjoint because we can see the intersection here. The shaded area means there's some element there that is in common in both X and Y. And normally if we want to find the intersection of X and Y, that would be the shaded area, which means element that is common in both sets. Disjoint said the element in X should be different from Y. So if there are some elements in X and Y that are common, they are not disjoint. So that's what they tell us. The shaded area here is called the intersection of two sets. Intersection of two sets means the element in X and Y are the same. And we use the symbol upside down U. So intersection of A and B is written as A intersect B. And is defined as X, all the elements in A and also the element in B are the same. A intersect B. Now, intersection again said a set of all elements that are simultaneously elements of set A and B. So let's see an example here. Here we have set A, and set A have 0, 1, 2, 3, 4 up to 10. The period here means we continue 1, 2, 3, 4 up to 10. Then set B is negative values up to -2, 0, 2, and 4, and infinity. Now, to find the intercept of A and B, it means we want to see the elements that are in common in both sets. So we can see that here, 0 is common, 2 is common, 4 because we have 0. Here go up to set A will start from 0 to 10. Set B start from negative infinity to positive infinity. So we have the 0 common, 1 is not common. So 2 is okay. Then we're going to have 4 because here we have 1, 2, 3, 4, 5 up to 10. So we are going to have 4, 6, 8 up to 10. So it means set A and B, the common element are 0, 2, 4, 6, 8, and 10. Because set A go from 0, 1, 2, 3, 4 up to 10. Set B start from negative infinity, and they are even numbers, -2, 0, 2, 4. So the next will be 6, 8, 10, etc. But set A, we go only up to 10. So we can go 12, 14. They are not common. Next is the union of two sets. A union of two sets means all the elements in both A and B together. So we saw the intersection means all the element that is common in set A and B. Union means all the elements in both A and B. So for example, here we have A equal to 0, 2, 4, 6, 8, 10. And B gave us 0, 1, 2, 3, 5, 8. A union B will be 0, 1, 2, 3, 4. We have 5. We have 6. And we have 8 and 10. So we can see that A union B is all the elements in A and also all the elements in B. There's no duplicate. So for example, we cannot write 2 because A have 2 and B also have 2. So we are going to write 2 2's. No, we don't write the duplicates. So we talk about the disjoint set, which is opposite of intersection. The disjoint set means we have two sets and they don't have all the elements are not common. So two sets that share no common members. And we saw that also shown in the Venn diagram. So the intersection of two sets will be empty set for disjoint because there's nothing common. Example here, all natural even numbers and also all natural odd numbers. Even numbers and odd numbers totally different. So this set A and B are disjoint. We see also the union of two sets is a set that contains all members of the two sets. So again, we have A union B means X belongs to A or X belongs to B. So everything in A and also everything in B. When we use N, it means both. So we can illustrate this also using the Venn diagram. The Venn diagram in figure 0.5 is intersection. So we have set A and set B. Where we have the shaded area means the element that is common in both A and B. This is union because we shaded the A, everything in A and also everything in B, both A and B are shaded. But the intersection section, we are not going to have the duplicate. We take only one at a time. So next is the set complement. A complement of A means not A, not A. So for example, if I have set A and we have the element 1, 2, 3, not A means it can be anything, but not 1, 2, 3, which means, let's say we are using the universal set that the values are from 1 to 10. And A is 1, 2, 3. So not A will be 4, 5, 6, 7, 8, 9, 10. So the complement means, actually that's what is given here, S not belongs to A. And also this is the Venn diagram. Again, this is our intersection again. But the complement is shown here. We can see that if A is a circle, not A will be outside. Not A will be outside. So that will be the conclusion of this lecture. So in this lectures again, we went through the basic concept of sets and also the set operations, which is the intersection, union, what is a disjoint, and also the complement. So again, see you in the next lectures. Thank you.